All right, today we're pulling back the curtain on one of the most fundamental, most important operations in any Unix-like system, the exec system call. This is the secret sauce, the magic trick that explains how your computer runs, well, pretty much everything.
I mean, you've done it 1,000 times, right? You're sitting in one program, your shell, maybe bash or ZSH, and then boom, a totally different program just runs. How does that switch happen so fast, so seamlessly? Kind of feels like magic. Well, today, we're going to learn the trick.
And it really is a clever trick, one performed by the operating system itself. But it isn't magic, it's a core concept that lets one program completely hand off its entire existence to another one.
So here's the central puzzle. Your shell process is just running, minding its own business. Then you tell it to run ls. The shell doesn't just, open a little side window for ls. No way. Something way more dramatic happens. It has to completely transform itself.
To get this, you have to meet the dynamic duo of process management, fork and exec. First, your shell uses fork to create a perfect clone of itself. Bam, a new child process is born. Then that child process uses exec to become something else entirely. So think of it this way. Fork is the cloner, exec is the transformer.
So what is this transformation really? Well, the absolute best way to think about exec is as a kind of brain transplant for a running process. Yeah, a brain transplant. It's a powerful analogy, so let's break it down.
Okay, so picture this. A process is like a person. The body is its identity, its process ID, any files it has open, its environment variables, that kind of stuff. The brain is what it's actually doing, the program code, the data, the memory. Now, fork just clones the whole thing, body and brain. But exec is the mad scientist. It keeps the original body, but it swaps out the entire brain for a brand new one.
So, this brain transplant idea is cool, but what does it actually look like on a technical level? What parts of the process get tossed out and what parts get to stick around? Let's get into the nitty-gritty.
So here's how the operation goes down. First, the old brain. All the code, data, stack, all of it is completely erased, gone. Then the new program's code is loaded in, and execution starts completely fresh, right from its main function. But here's the crucial part. Notice what stays. The process ID is preserved. It's still the same body. And maybe most importantly, file descriptors, like for your keyboard and your screen, stay open. That's exactly how the new ls program knows to print to your terminal.
Now here is a detail that might just bake your noodle a little bit. If an exec call is successful, it never, ever returns. Think about it for a second. Why would it? The code that made the call doesn't exist anymore. It's been completely wiped out and replaced. So the only time you will ever see a return value from exec is if it failed.
Okay, so if you've ever looked up code examples, you've probably seen XCL, XXVP, XXVE, a whole mess of them. And you might be wondering, why are there so many different versions of the same command? Well, let's decode this alphabet soup.
The reason, honestly, is just for convenience. They all perform the exact same core brain transplant operation. They just offer you different ways to tell the operating system what program you want to run and how to set it up. Those different letters at the end of the name are just clues to what they do.
First up, we've got L versus V. This is all about how you pass the command line arguments to the new program. The L stands for list, where you just pass each argument one by one, as a list right inside the function call. The V stands for vector, which is just a fancy name for an array. So for that one, you bundle up all your arguments into an array first, and then pass the whole array.
Next, we have the P suffix, and this one is super useful. P stands for path. If you use a function that has a P in it, you can just say ls, and the system will go searching for it in all the usual directories, just like your shell does. If you use a version without the P, you have to be super explicit and give it the full file path, like bin/ls.
And finally, there's the E suffix. E, as you might guess, stands for environment. By default, the new program just inherits the environment of the process that called it. But if you use an E version, you can handcraft a totally new and custom set of environment variables for it. This is really powerful for things like security or running a program in a very specific context.
So let's put it all together. This table sums it all up really nicely. You can see how you just mix and match these suffixes to get the exact behavior you need. Want to pass arguments as a list and have the system search the path? You use XXLP. Need to provide an argument vector and a custom environment? You're looking for XXV.
It's a pretty logical system once you know the code.
All right, enough theory. Talk is cheap, right? Let's see how this actually works in a real piece of code. We are going to transform a running C program into the ls-l command right before our eyes.
For this job, we've picked XXLP. It's a great choice because the P means we can just say ls and the system will find it for us, and the L means we can just pass the arguments in a nice simple list. This one line right here, this is where all the action is.
Let's break this line down. The first ls tells exec p to go find the program named ls somewhere in the PATH. The second ls is a convention called argv0. It's what the ls program will think its own name is. Then comes -l, which is our actual argument. And finally, that null at the end is absolutely essential. It's a little stop sign that tells the function that's the end of the argument list.
And if our program runs that line of code successfully, this is what we see. It doesn't print hello from my C program or anything. Nope. Our program's memory, its very existence, has been completely replaced by ls, which then runs and prints its familiar output. The transformation is complete.
Okay, so after all of that, if there is just one thing that you remember from this whole explainer, what should it be? Let's crystallize that core idea.
This right here, this is the whole ballgame. Fork is about creation. It adds a brand new process to the system. Exec is about transformation. It fundamentally changes what an existing process is. They are the one-two punch that powers almost every single command you run.
And this brings us right back home. Exec gives a process a totally new purpose, a new mission, without changing its core identity. Its process ID is the same, its connections are the same, but its code, its reason for being, is now completely different. A new brain, but the same body. And that leaves us with one final thought. The exec call is all about starting a new task. But what happens at the end? How does a process signal that it succeeded or that it failed? And how does the parent process that started it all find out what happened? Well, that is a story for another day. Thanks for joining me.